Hey everyone, how you doing? Trust everything is going well. It's been a while since I actually have done any videos on satellite telemetry, following what the data is indicating, and doing our best to make predictions on this. And when we talk about planetary events happening to us, our planet, of which we're on, nowhere else to go until you leave here, um, it's good to know where and what satellites are doing. And there's a lot of satellites up there. You can plug into them, in which in this opportunity you can. You can become very knowledgeable very quickly. So anyway, this is what we call integrated space weather. It's iswa.com. And it's you can see the rest of it. I'll leave the link. And this is where I cut my teeth. I learned about what was going on, how to begin to read, interpret the data. And as an observer, I think it's important that you learn where these resources are and that you take responsibility of seeing the data yourself so that when there is a headline that comes out or a YouTube channel that's doing something, you'll have the knowledge to either refute it or to, in fact, back it. So here you can see we have a number of different headings. Some of these are no longer operational. Many of them still are. Here's with our sun. You can go and see what the KP indices are. Now, you can learn what planetary KP index is derived from calculating a weighing average of K indices from a network of geomagnetic observatories displayed on a bar graph with color coded by NOAA geomagnetic storm scales. And this is what everybody uses. You can come in here, you can get some predictions of where, and you can actually go and you can see that this is real time. Any point, you can do a data point. Discover. This is where we get the data of whether or not we're in a geomagnetic disturbance. And oddly enough, as I look at this, we are. This is interesting. So this is most likely from the effect of the coronal hole stream that's coming in. This is where the electrons should be normally within the scale. So we're in a slight geomagnetic storm. So yeah, so you can see how that works. That's pretty cool. The proton flux. This is a really cool tool. If we're in a heavy geomagnetic storm, we can actually see what the release of the protons are. And these are from a number of different satellites. You can put this into real time, and it'll actually show you the telemetry. So very good tools to use. You can learn what plasma density is. It teaches you exactly how the models and the prediction models work of what plasma is. You learn those tools and you get to be a lot more smarter. Like for instance here's the heliosphere of the inner planets. And this is from INYEL, which is a combination of a number of satellites that allow us, let me pull the data up, there we go, and we can see if the Earth is in line to be affected, say, by a CME. So to get your orientation, here is Earth. Here's the yellow. Mars is right where this is, and it lets you know where the planets are. Gives you the data as well, stereo A, stereo B. And so from here, we can see if there's any type of reverberations. And many times what I found is that as you go further out into space, by the way, you've heard us talk about many times stereo A, stereo B. Here is Earth. Here is where those satellites sit. And here is stereo A, stereo B. B, they say we're not talking to it anymore. So now you can get an idea. And then these two satellites are looking directly towards the sun. So anything that falls into the path, they see. And by the way, they can see in and out. So this is kind of cool. Nothing here. Now, you can go over here to the sun as well. Here's where we can actually, and you can see the raw data and where the data is coming from. So this is just a very quick, here's the proton flux as it's coming directly off the sun. So you can see the data yourself, all in real time. And once you become more versed with the tools, you'll be able to see where all the reports people come with, like suspicious observers and others, where they get the data at. And there's places now that actually do this. I mean, you can see the sun as it slowly rotates. Pretty cool, huh? All right, so why I did this, I just took 10 minutes to go through that, is let's go over here to the magnetosphere. And we're going to spend some time today dealing with two particular models. And I'm just going through here so you can see these yourselves. Go and check them out. Experiment with them, have fun with them, etc. So we're going to go over here first to what we call the SWMF cut, the Y cut. And it explains to you right here what the magnetosphere, the Battris Y-cut magnetic field lines cut through the Battris MHD model of the magnetosphere in the GSM Y equals to 0 plane. The model is fed by solar wind measurements, plasma density, temperature, speed, and interplanetary magnetic field from ACE at L1, and it gives you where that satellite is. This is the 2011 version, includes RMC modeling and the inner magnetosphere. Disclaimer, the ISWA real-time SWMF simulation should be considered only as science and prototyping quality. The derived real-time SWMF data products are experimental and undergoing evaluation phase of development. Did you get all that? So, you understand how they're getting the data, where the data is coming from, and if they're looking at this data, well, we should look at it as well. Now, they'll come up with their own determinations of what the data is saying. So, again, remember what we're looking at. Density, heat, and speed, all connected to the magnetosphere of our planet. Orientation. This is GOES 13, no longer. GOES 14 is coming down, and they haven't updated the models because they'll put on there GOES 14 and now GOES 16. Here is the moon, which is right there. And so let's take a look at this. The field lines. IMF is the inner magnetic field lines. This is what Earth connects to the sun and other planets. The polar cap, these are what we would call magnetic field lines produced by the Earth that typically are a signature of what we encounter from the solar wind, which is this here, closed IMF lines. This like you're dealing with an electrical circuit. It's what a magnetic circuit is as well. And you can see it's really hot, even hotter than what's coming off of the sun. This is an interesting one. These lines, again, are the solar system, what I call connecting lines, magnetic field lines. And then you can see the bow shock of what happens when our Earth's heliosphere and magnetosphere reacts to the sun or anything else. You can see how the plasma is heated and is thrown off as we go through the galaxy. So let's put this into now. This is what I find interesting. I'm going to stop it here. So this is plasma temperature. This is super cold plasma. And look at the closed loop lines coming off of the Earth. And you can see we actually have our own kind of a corona. Now watch as these, here's another anomaly coming off. And this is remarkable when you look over here at your legend, getting a basis. This is super cold. So here you can see, which I find very interesting, you have this secondary bubble coming off of our planet. Our planet's producing this. Look at this. It's a perfect, I don't know, it could be maybe a case for a stellar core. I don't know. It's super hot. I know that. And look at the effect on the back of, and there's our moon right there. So this is really interesting. And look at the uniformity of the IMF lines. And this is what I do a lot to, well, quite frankly, it's a good form of meditation. I know it sounds weird. So we're going to do a little, I just wanted to show you what typically we could look for. So we're going to put this one to the side, and we're going to come here. Now, this one here is what we call the Z-cut, the solar wind velocity. Now, it goes through the models again. This model is fed by the solar wind measurements, plasma density, temperature, speed, and again, interplanetary magnetic field lines. All right. This one focuses on the reaction our Earth has to the flow coming off of our sun. Okay. We call it the Z-cut, and we'll come right back into here. So again, let's take a look at what we're looking at. It's measured in kilometers. Again, dealing with the scale over here. And these are this, obviously, the stronger the arrows, the more intensity of the wind, the ions. So let's check this out. Let's run it in real time so you can see. And again, now this one is mirroring exactly. So when we see that anomaly that we saw on the Y-cut, this is validating that. And again, what I find interesting is the reaction of the bow shock. It's not that hot coming off of the sun. We can see our scale right here. And you can see the intensity of when it's hitting. It's kind of like almost the sun and its corona. Yeah, this one is interesting. So we're going to stop this. And we're going to come back to these models to do some. I think you're really going to enjoy this. And I know this is going to go a little long, but that's cool. So this one, the Z-cut, this one shows us the magnetosphere on a plane. And you can read it for yourself, with the white semicircle shape showing a model computed location of the dayside magnetopause. Usually the rightmost position of the semicircle is about 10 Earth radii upstream from Earth. So just figure 10 times the Earth's radius. The most sunward boundary position is called the magnetopause standoff position. The WMF version includes the RMC model, and they give you the same data as before. So let's pull this up. And when we get into these intensities of geomagnetic storms, this is where you should go. Now, I go over here and say, all right, well, what are the models showing? Because the models are taking the data telemetry off of the satellites. So again, Earth, right here. Now we go out 10, all the way out here. This is where our magnetopause goes. And look how it's reacting to this. Now, I find this really kind of concerning, to be candid with you. And we won't get an explanation of the data, but look at this. What this is telling me is that we have low density from the sun, but something is causing our magnet. I'm going to try to stop this so you can see what the data is showing. Look at this. There is a lot going on out here. That's plasma reaction. You know, the electric universe. And you can really begin to see what's behind the planet. Most people only look at this, think it's the sun, but we're putting off a signature as well. Look at that, how it lights up. And you can see the reaction. Extremes in temperature, density, and speed. And here are the satellites that orbit the Earth, so you can get an idea. So you see what look at this. That looks to me to be electric in nature. Electric and magnetic go together. Look at that. Amazing. All right. So let's put this one to the side for the moment. Now, I want to show you something. We're going to go up here to the Y-cut. And we're going to go to a date that proved to be disturbing our magnetopause. So what we're going to do, and you can learn how to consider this a tutorial. We're going to go to March, and we're going to go to 2017, And we're going to start out on the 12th. And okay, and we hit apply. Now, two things. Notice the consistency and the density of the temperature coming off of the sun. You can see again how our planet has this beautiful, it's genius. It protects us, and you can see how it has this normal flow, right? Now, watch what happens the next day. We're going to go in here, we'll hit apply. Are you catching this? We're going to stop it down so you can see it. Something is perturbing our planet. And by the way, that's why I know that there's something out there. I don't know what it is. Stellar core, dead sun, I don't know. Big planet. All I know is years, folks, I have been looking at this. There is something out there. Look at the closed loop lines. It's drawing. It's like it's being fed off of. And you can begin to see something is happening. Remember on the Comet Venus video? Now that's just wild. This should not be happening. You should not have these closed loop lines, magnetic lines going out here. It should be exactly what it should be right here, as they say, within the Earth. But look at this. And you can see it's hot. It's not cold. It's hot. Okay, now let's go to the next day. Are you wanting to see crazy, folks? Check this out. This is what blows me. And by the way, this is happening more frequently. This is what really takes me aback. This is going out towards the sun. That should not happen. It shows that our planet has lost connection to everything around it. Our closed magnetic lines are just absolutely off the chart. The polar cap which is supposed to be going out here to the rest of the solar system, something has completely interrupted, and it gets even stranger. Look at that. You can see what I'm talking about. Now, here's the interesting thing, and you can learn this. Again, we go by our graph, our scale right here. This is dense, cold space. Plasma, yes, but cold plasma. This is heated up. This is above at the 0 point. And look at what's happening. You starting to see this? Now, again, this is saying to me what I'm seeing this. The magnetic lines that we connect to, our interplanetary magnetic field lines, are virtually non-existent. Something has literally stripped that away. And look how it's being fed reversed. Look at that. Crazy, crazy, crazy. And here you can see what I'm talking about. These intermagnetic field lines are like a separate source other than our planet. Wild, isn't it? Look at this. And this is intense heat. All right, and then we'll wrap this one up by going, I could give you the next 4 or 5 days. You do it yourself. You'll love it. You'll have fun with this. And here we go. Look at this. Now, you see what I was talking about? This is what it should look like all the time. You should not have these magnetic field lines going towards the sun. And again, you can see the reaction here of the plasma density. And look at that. Huge. I mean, folks, these are just the space we're talking about here. We're approaching millions of miles. So now let's go and see what it looked like on the Z-cut. Let's pull this one up here. And we're going to go to the same dates. We'll go up here to, and again, it's very easy once you learn. Go here to March, go to the 17th, and I think we started on the 12th. Now, stop. So, these lines, again, should only be going in one direction, and around our planet, you'll see that they will deviate. We should not have what we would call a reverse wind coming from space, the solar system. And you can see, again, look at this. There is something happening these where we get these, and I'm beginning to think that these are Claudia's stellar cores, because they interrupt the ion trail, and you can see how they produce their own unique signature. So we'll go up here. Now check that out. Let's just stop here a second. Look what's happening. It's coming in here, and we're even getting oscillation of what we would call reversed field. And you can see there is something here. Look at this again. More indication. Look at this. And, you know, it's like almost watching, you know, wind. Because it's what it is. And whatever is really heating up here, you can see something is reacting as well. And obviously, the stronger the arrows, the stronger the wind stream. Look at that. All right, so let's go. Let's continue with the 14th. All right, let's stop. This is strange, folks. I'm just telling you, it's strange. You should begin to understand immediately and see we got a problem here. Our plasma temperature has dropped precipitously. There is a complete collapse of any type of wind, solar wind, ionizing streams coming off of the sun. None. This is coming primarily from Earth. This is why I know something is going on. I don't talk about it a lot, but now you can begin to understand. And then what's even stranger is that why we're getting this interruption, but look at the ions. Still, this is hours now. We have, you can almost see that there is something right here. It's pushing out in all directions, even back on the Earth. And again, the plasma density is almost non-existent. And you can still see it now. There is something here. This should not be happening. And you're getting almost kind of a return effect. And now you can begin to understand. We're getting, again, return back to the intensity of the heat. But again, look at this. You can see the cavitation right here. And then how it swoops in. Again, look at this. Kind of put this in perspective, it's like we're getting something blowing on us from, this is the sun right here. Let me annotate it this. So the sun is here. The wind should be coming this direction. Not swooping in like this. This is like something is countering this. And then look how it is either by the earth and then it wraps and heads back out. Yeah, you can see it's definitely different. Let's continue. Now you're seeing it. Now look how the return is coming back. Still, now we're getting just the opposite effect. Look at this. And here, it's going directly towards the sun. Still nothing coming from the sun. Nothing. And then we'll finish the frame out. Now check this out again. It's as if, and this is what I really, well, I think we'll talk with Claudia a little more on this, because here appears to be, as you can see, going directly towards the sun. Now, what is strong enough to have this type of indication going against the sun? I mean, it's odd. And then we have the complete reversal here. Absolutely, in this area, it's as though it's virtually no energy. And then we'll stop here. You can continue on to this yourself, but check it out. Now, the last one we want to take a look at is on that same date, so we can see that whatever happens, and you'll capture these yourself. If you actually start using this tool yourself, you'll begin to pick up on this really quick. So now we're going to go back. Let's go back to the 12th, and we'll apply this, and let's see what happens here. Now you see the difference between what we're having today, where there's virtually no heat. But you can see the heat signatures of the plasma here. Now let's go to the 13th when we really started seeing these anomalies. You can almost see it now, what we're talking about. Look at the same impact, just in a different graph, a different model. And then let's go to the 14th. Oh, check this out. All right. What's the first thing that you see wrong here? Well, folks, this line should never be broken. It should be around our planet. It's not. Something big, nearby, close, whatever. Look at this. Something is pulling, and you can actually see it right here yourself, how it's being drawn towards something over here. And something over here is pulling this. And this line should not be like this. This line should be like that. Let's let this play some more then. Look at that. What's happening? All right, little drawing again. I love this tool. Still being drawn here. You can actually see it's actually coming out in this direction. And not a closed loop. Something has pulled it like that. Frame again. This is closed. It shouldn't be like this, but you can see that something is really just wreaking havoc with our magnetopause. Look at that. You can actually see it moving. Excuse me, I want to let that play out again. Look at this. So what's the problem here? I hope you're staying with me on this, and even if you're not, those who do, we're enjoying it. Here's a big problem here, folks, right here. Something is not right. The Earth has no protection. None. This line, it should be around our Earth. Look at that. Completely pulling away. And look how intense it becomes. And you can see it's being drawn again to something out here. Let's go to the 15th. Still, it cannot make a connection around the planet, as it should. Now we're getting, you can just see the intensity. It was a huge disturbance. This absolutely wreaked havoc with, our internal system. Well, there you go. And the rest is history. So I hope you enjoyed this. Get a chance, check it out yourself. It's well worth it. It really is. You'll have a great time with it. And I hope that you'll learn how to use this tool and you can become one smarter observer. All right, folks, we'll talk soon.